Hey guys, welcome to the 5th episode of GCSE Maths, Fractions, Decimals and Percentages. So, just before we start this video, please make sure to like and subscribe. It helps us create more videos and helps you. Also make sure to turn on the notifications bell, so then whenever we post, you're always up to date. Thanks guys, now let's get on to the video. Hey guys, this is the 5th episode of GCSE Maths with me, DP Education. Today we're going to be learning about fractions, decimals and percentages. Let's get on to it. So, these are some of the core ideas that you need to remember for your exam. So first thing, the one word that describes all of these three things, fractions, decimals and percentages, are proportion. They are all ways of expressing proportion. Also, they're interchangeable, so we can switch out a fraction for a decimal or a decimal for a percentage. All of these conversions work. And we need to learn how to convert between them. Okay, so the conversions. From fraction to decimal, you just need to divide. So for example, if it's here 7 over 20, it's 7 divided by 20. Or if it's, let's say, 18 over 93, you do 18 divided by 93, and it gives you a decimal. In this case, it's 0.35. From decimal to percentage, you need to do times by 100. For example, 0.35 times 100 is equal to 35%. Now, let's go down. Percentage to decimal, you just divide by 100, the same thing. But the decimal to a fraction is a bit different. We'll talk about that a bit later. So, now we'll talk about terminating decimals to fractions. So like I said before, we'll deal with this one later because it's the harder one. So, a terminating decimal, which is the ones that end or are finite, basically, the digits after the decimal place go on top. Then a power of 10 on the bottom, which is the same number of zeros as they were decimal places. So for example, for 0.6, the numerator would be 6 because it's the digits after the decimal place. And the power of 10 on the bottom, since there's only one 0, it would be 10. I think you get the hang of it. Now, let's talk about recurring decimals. So, recurring decimals are a pattern of numbers which go on forever. For example, 1 over 3 is the decimal 0.33333, etc. Also remember that it does not have to be a single digit that repeats. You could have, for instance, 0.143, 143, 143, etc. So, if there's only one dot, it means that that single digit is only repeated. However, if there are two dots, then everything from the first dot to the second dot is repeated. So, for example, 0.25 with a dot on top of the 5 is 0.25555, etc. But 0.2 dot 5 dot is equal to 0.25252525, etc. Let's continue. So, now, like I said before, we'd come back to recurring decimals into fractions. So these are the basic ones. So let's say you had to write out 0.2.34 as a fraction, recurring as a fraction. Name your decimal first. I'll call it R. So let's say R is 0.234 recurring, all of it. Now, you need to multiply R by a power of 10 to move it past the decimal point by one full repeated lump. So here that's 1,000 because there are 3 different digits behind the decimal point. So 1000R is equal to 234.234 recurring. Now, to get rid of the decimal place, we can we can minus from 1000 r. So 234.234 recurring minus 0.234 recurring is equal to 234, or 99r. So r is equal to 234 over 999, which is equal to 26 over 111. This works for many things. However, as you'll see, it doesn't work for all. So let's say you had to write 0.16 recurring as a fraction, but this time only the 6 is recurring. First, like we did before, name your decimal. Let r be 0.16, 6 recurring only. And then multiply r by power of 10 to move the non-repeating part past the decimal point. So 10r is equal to 1.6, because the 1, which is not recurring, would come onto the other side. Now you want to multiply again to move one full repeated lump past the decimal point. So 100r is equal to 16.6 recurring. Now what you want to do is subtract to get rid of the decimal part. So this time it would be 100r minus 10r. So that's 16.6 recurring minus 1.6 recurring. So 90r would be equal to 15. And then you just rearrange it. So r is equal to 15 over 90, which is equal to 1 over 6. So now we'll talk about fractions to recurring decimals. So you might find this cropping up in your exam too. And if they're really unpleasant, they'll stick in a non-calculator paper. So here's an example. Write 8 over 33 as a recurring decimal. So there are two ways you could do this. So the first way, which is shown, you could find an equivalent fraction with all lines on the bottom. The number on the top will tell you the recurring part. So for example, 8 over 33, to get to the nearest one denominator with only 9s, you would have to multiply the numerator and denominator by 3. So 8 becomes 24 and 33 becomes 99. Meaning that it's 0.24 recurring, all of it. The second one we won't talk about, but just so you have a feel of it, you could just do it by short division, the bus stop method. It's not great because sometimes it can take a bit too long, but yeah. So guys, that's the end of this video. Thanks for watching and make sure to like and subscribe. See you in the next one.